So recently, the team behind ACE just released some demos showcasing the capabilities of the framework. Inside the demos folder, here we can find several projects that show the flow of the ACE framework, starting from ACE-AF all the way down to Stacy. Now, after playing around with some of these demos, I thought it'd be a neat project to create a front end that could visualize the flow of the ACE framework. So, for the past few days, I built this. So on the left side, here we can see the chat that is used to interact with the actual ACE framework itself. And on the right side shows the visualization of the flow of the ACE framework, starting from the task prosecution all the way up to the aspirational layer. So in this situation, it's usually better to show rather than explain the whole flow. So we're just gonna go ahead and send a message to the autonomous agent that's being run by the ACE framework. So the message that we're going to send is next response. Once we send that over, it should open up the task prosecution. And inside the task prosecution, we can see here the bus messages received. We can see that no north messages are sent yet. There is one south message sent, and this is being fetched from the south bus 5 from the cognitive control in this scenario. And the last response that it's taking in is the user response, this being user next response. Now, the neat thing of this visualization is it also has a stepper function. So we can press this play button in order to go to the next step. So when we hit this play button here, what happens is it then takes those messages from the bus and generates the LLM message for the task prosecution. So you can see here in this situation, it's choosing to create an LLM message saying south, request to interact with educational databases API to identify resources and opportunities, and so on and so forth. And in the north message, it's saying task sequence initiated, identifying educational resources, analyzing equity metrics, and so on and so forth. So when we click onto the next play button here, the next step shows is it takes the message that was just generated and saves it up to the north bus over here where it's saying saving response. Now, once we go through, we'll click again. You can see the cognitive control goes next. Once again, it fetches the information from the south bus 4 from the executive function, and it retrieves the bus messages from the north bus 5 from the task prosecution. And we can see that these information also lines up. So we can see the north information lines up with the task sequence initiated from layer 6, identifying educational resources, analyzing equality metrics, proposing sustainable development projects, and ensuring respect for individual liberties and human rights. And from the south message, it's saying from layer 4, allocate resources to tasks promoting education, equality, and sustainable development. Prioritize actions that respect individual liberties and human rights. Now, once we go to the next step, it takes that information, generates the LLM based on the information from the buses. And so we can see here for the south message, continue task sequence, identify educational resources and opportunities, and so on and so forth. And in the north message, we can see here, it says task sequence ongoing. Resources are being allocated to promote education. So going on forward, it just goes through this loop where once the LLM message has been created, it saves it up to the buses. So you can see here saving response to the north bus for the cognitive control and the south bus that will be passed down to the task prosecution. And it just goes through this loop of fetching the bus messages, generating the LLM message. So we can see here, it's going to be streaming it through. And then once it finishes creating the LLM message, it then saves that response up into the buses. And so it's going to transport that information through the north bus. That's going to be the telemetry to the agent model. And it's going to go down to the south bus, which is going to be the line of command that tells the cognitive control, hey, this is the next thing to do. And so we're just going to step through the rest of the layers. So next is the agent model, generates the LLM message here. So it goes through, streams the output, saves the response, goes up to the global strategy. Once again, gets the bus messages, generates the LLM message. We see the LLM message being generated, saves it again, and it goes up and up. Now, here's the important part is the aspirational layer. Now, since the aspirational layer is the top layer, it can't go any further up. So within the code base, there's logic put in where it has to understand that it needs to pivot in this scenario. Now that it's hit the aspirational layer, it's once again fetch the best messages, generates the LLM, but now it's smart enough to know that once it hits this top layer, it pivots, and now it saves the response down to the south bus for the global strategy, and then it goes back down to the global strategy once more, thus going into a full circle. So we're now starting from all the way up, and now we're going down. So we're going down to the global strategy. Once again, bus messages, feel like a broken record, saying this over and over again. Bus messages, LLM messages. Once it gets through, say the response. The response gets fetched. We're now in the agent model. This just shows what it's capable of and what its resources and what its restraints are. Once it's gone through that, we have the executive function, retrieves the bus messages, generates the LLM message with the new information that's being passed down. Once again, saves the information, and then it goes inside of the cognitive control where it fetches the bus messages again, then it generates the LLM message. Once it does that, it saves the responses into the corresponding buses, and then afterwards, it finally goes to the task prosecution where it fetches the final bus messages. So since it's the lowest layer, it has no north messages and it only has south messages to fetch in this scenario. And we can see here after it fetches the bus messages, it generates the final LLM message. And then once that's finally generated, it puts it into the chat message for it to respond back to the user message. So wanted to point out some of the differences between Python Flask React. Here, this being the visualizer that shows the flow of the ACE framework that we just saw, and the project that it was forked from, this being the Python Flask Easy project that was created by David Shapiro himself. And so going inside the Python Flask Easy project, specifically, we can see here that there were only two endpoints in the Flask server, that being the post message and the get messages. And as the name explains, the post message takes the responses from the layers and then saves it into the logs folder here with the naming schema of log, then the timestamp of the message, which bus it's going into, and the layer number itself, and then just dumps that into a YAML file. And then the get messages is the corresponding mirror of that functionality where it takes those messages from the responses of those layers. And the key thing to note in this scenario is that it takes all of the messages from the logs. It takes all the messages from the logs, it appends them into messages in this scenario, and then it filters for the appropriate logs based on which bus it's going through, and then it only takes the first 20. Now, I made a bit of a deviation in my own project here for the Python Flask React. Instead, what I did is I broke it down into 3 endpoints to help illustrate each of the steps of the flow of the ACE framework to really show it on the front end. And the 3 endpoints that I used here in this scenario is get messages, chat completion, and save response. And inside get messages, it's very similar to the get messages inside of the original project, but instead what it's doing is instead of getting all of the files from the logs and only getting the first 20 that's applicable for that layer, what instead it's doing is getting only the first log from the layers that are applicable to that layer. And so what I mean by that is it takes one log from the south bus directly above that layer, and it takes one log from the north bus directly below that layer. And so the reason why it only takes one log from above, that being from the south bus, and from below, that being from the north bus, is because of the OpenAI rate limiting. I believe it's only 10,000 tokens per minute. And in the original implementation for get messages, if we were to take the first 20 messages, that being the first 20 most recent messages, it would very easily hit the OpenAI rate limit, which is why I opted out to create a much more simplified version that only uses one message. Now, obviously, there's pros and cons to this. Pros of this is we don't hit the rate limiting as much, But the con, obviously, is we don't get nearly as much context, so there's a trade-off in that scenario. So then the next endpoint is the chat completion endpoint. And just really simply, all it's doing here is it takes the messages that's retrieved back from get messages, and then it uses that messages along with which layer num it's applying to, and then it uses the chat completion from OpenAI in this scenario. So once it takes the chat completion, it then streams the response of the output from the chat completion to the front end. And then now the last endpoint that gets called is the save response. And inside the save response here, it takes the response from the chat completion and then it saves it inside of the logs in this scenario. And the logs will be then split up into their own respective layers. So you have this layer 1, layer 2, all the way down to layer 6. And you can see in this scenario, you can see for layer 2, this is a good example. It has here log, the timestamp, and then which bus, and then the layer. And then also importantly, it also has a response.txt. So I'll get into that in a bit. The next thing I wanted to point out is the differences between the layers and how they're set up. So inside of the layer 1 from the original project, we can see here that it only concerns itself with taking the messages from the north bus and only sending messages to the south bus. This makes sense since it is the top layer. Similarly, I mirrored that exact same implementation, but did it in the top layer.py. And here you can see the same functionality being mirrored from layer1.py inside of top layer.py. We can see lines from 9 to 12 is effectively the exact same in the get messages function. The lines from 19 to 13 in the original project effectively mirrors the function of chat completion. And from lines 22 to 20, it effectively mirrors the functionality in save response, albeit one exception, that being the set response. So going into the set response here in the scenario takes the response from the layer, that being in this scenario the chat completion, takes that response and then saves it inside the response.txt. Now the question is, why do we do that? The reason being is, looking at the original project, what's being done here is the response is being saved inside the layer itself. That way it has a way to be able to feed back the last previous response that it gave in into the template for the prompt, so that the LLM has context knowing what was its last response before completing and generating the next response. Moving on, the next and probably the last biggest difference is the difference between all of the other layers. And so looking at the original project, specifically looking at layer2.py, we can see here that it follows this format of fetching the messages from the bus, that being from the north bus and the south bus. And here, very similar, takes the messages from the north bus and the south bus and then puts it into the chatbot for it to create the LLM chat completion. And then finally, it then posts that information, parsing the south and the north, and then sending those messages up to be saved into the logs. And so you can see here that for layer2.py and layer3.py, they're effectively the same file. And the only difference is the layer num in this scenario. So we can see here in layer2.py, obviously, it's going to be representative 2. And layer3.py is going to be representative 3. So with that in mind, what I did instead was I just abstracted it out and just created a file called layer.py that's responsible for all the layers below layer 1. So 2 to 6, effectively. And it mirrors the exact same functionality, where we have the north buses and the south buses being fetched inside of the get messages function. We can see here is the chatbot LLM completion happening inside of the chat completion functionality. And finally, we also see is the splitting and the formatting of the responses and then saving it up into the logs being mirrored inside of the save response functionality as well. So some final thoughts. If you made it this far in the video, thank you. And if you like the video, do all the usual, like, comment, subscribe. But most importantly, since I'm just starting off in YouTube, I would really appreciate any sort of feedback that you guys might have of the breakdown of the visualization of the framework, ACE framework. And some final notes is I really appreciate the work done for the ACE framework and the team behind it. And it's just been some really exciting stuff going behind inside of the world of AI and the technological pushes and boundaries that we're seeing. Obviously, I'm extremely optimistic about this, as naive as a foresight as I do have. It's a pretty great one. Like seeing the fourth industrial revolution happening before our eyes, and really just the greatest time to be alive. So really thankful for all the work that's been done recently, and I'm looking forward to so much more. Great. If you made it this far, thank you very much. Hope you have a great day, and bye.